Building the future with machines, repair tech, and smart materials where construction meets creativity, strength, and a little magic. From molten steel to towering concrete columns, witness the fascinating journey of building materials powering modern construction industries. Once the molten steel reaches the required quality, it is transferred to a continuous casting machine. Here, the liquid metal is solidified into long billets, which serve as the semi-finished form for further processing. The billets are cut to specific lengths and reheated in powerful furnaces to make them malleable for rolling. The hot billets are then passed through a series of rolling mills, where they are gradually reduced in size and shaped into steel bars of various diameters. This rolling process enhances the material's mechanical properties by refining its internal structure. Precision equipment ensures uniform thickness and accurate dimensions throughout the production line. After rolling, the bars undergo controlled cooling on long cooling beds, which ensures proper hardness and toughness. The cooled bars are straightened, cut, and bundled according to market specifications. Finally, they are stored and transported to construction sites and industries across Indonesia. Through this advanced process, Bajamart delivers high-quality steel bars that meet both domestic and international standards, supporting infrastructure growth and industrial development. The magnetic separator on a conveyor belt is designed to efficiently remove ferrous particles from a mixed material stream. Initially, the material is fed onto the moving conveyor, which carries it towards the head section where the magnetic system is installed. As the material passes under or over the magnetic field, ferrous contaminants are attracted and held by the magnet, preventing them from continuing with the rest of the bulk material. Bello. This process can be performed using either permanent magnets or electromagnets, depending on the application and required strength. The non-magnetic portion continues along the conveyor and is discharged separately, ensuring that the cleaned material remains uncontaminated. The system is often positioned at critical points along the conveyor, such as the middle section or the head, to maximize separation efficiency. Magnetic separators are widely used in industries where metallic contamination is undesirable, including food processing, chemical production, and bulk material handling. Adjustable gaps between the conveyor belt and the magnetic system allow fine-tuning to capture particles of varying sizes. Regular maintenance ensures that the magnets retain their effectiveness and that captured metal is safely removed without interrupting the production flow. By continuously separating metallic impurities, the magnetic separator protects downstream equipment, improves product quality, and ensures compliance with safety standards, making it an essential component in modern material handling systems. Hamplee. Spiral UK is a leading construction company based in Helston, Cornwall, with 40 years of expertise. Specializing in designing, manufacturing, and installing bespoke staircases, they combine craftsmanship and innovation to create unique, high-quality solutions tailored to each project, earning a strong reputation in the industry. The mechanical connection system uses couplers to join rebars efficiently. Each coupler works by threading or swaging onto the bar ends, ensuring a secure connection. This method transfers loads seamlessly between bars, making the coupler as strong as the original reinforced concrete. Installation is quick, reliable, and maintains structural integrity throughout the construction. The concrete bunk slab at the cattle farm is constructed using the Slipform method, a continuous and efficient formwork technology. Initially, reinforcement bars are carefully placed along the slab layout to ensure structural integrity. Concrete is then poured into the Slipform machine, which moves steadily along the designated path. As the machine advances, it shapes the wet concrete into the desired profile, creating a smooth, uniform surface. The Slipform ensures precise dimensions and consistent thickness throughout the slab. Workers monitor the process, adjusting the flow and alignment as needed to maintain quality. After the concrete gains initial strength, the slab is cured to enhance durability and prevent cracks. This method allows for rapid construction of long, continuous bunk slabs, providing a stable feeding area for livestock. Overall, Slipform technology streamlines the pouring process, reducing labor and ensuring a high-quality, long-lasting concrete structure. Gosalia Concrete is a trusted name in modern construction, recognized for its expertise in delivering durable and precise concrete works. The company specializes in handling every stage of the concrete pouring process with professionalism, from preparing the formwork to ensuring the final finish. First, the site is carefully leveled and reinforced with steel bars to provide strength and stability. Next, high-quality concrete is mixed and transported to the site, where it is poured into the prepared molds. Skilled workers spread and compact the mixture to eliminate air pockets, ensuring solid structural integrity. Vibrators and leveling tools are used to achieve a smooth surface, while curing methods are applied to maintain durability. Gosalia combines advanced equipment with experienced craftsmanship, ensuring each project meets strict quality standards and results in long-lasting, reliable concrete structures. The installation process begins with the inspection of all delivered pipes, checking for cracks, dents, spalls, or coating damage. Lifting equipment provided by the contractor must also be reviewed daily, ensuring rated capacities are observed and damaged tools replaced. Before trench excavation, an embankment may be required. Depending on pipe size, utilities must be marked, and the trench width should equal the pipe's outside diameter plus 4 feet. For trenches deeper than 3.5 feet, the slope must be laid back properly. The bottom is compacted and proof-rolled using approved equipment. If deformation occurs, unstable material is removed, dried, and recompacted or replaced. Bedding is prepared to 6 inches depth, using specified aggregate depending on pipe type. Pipes are placed with correct orientation, alignment, and slope, and joints are sealed according to material requirements. For concrete pipes, joint caulking is applied inside and outside, while elliptical pipes also require geotextile wrapping. Metal pipes are joined with bands or geotextile, and thermoplastic pipes use preformed gaskets. Pipes connected to drainage structures must be cut flush and sealed with mortar. Hakna. Backfilling begins with placing aggregate along the pipe sides in compacted lifts using hand-operated equipment. Proper lateral support is critical, particularly for thermoplastic and metal pipes. Shoring or trench boxes must follow the specified procedures. Over the pipe crown, uncompacted cover is maintained 1 foot for metal and thermoplastic, 2 feet for concrete. Backfill material varies by location. Coarse aggregate is required under roadways and shoulders, while soil or granular fill may be used in other areas with density testing. Compaction must follow equipment-specific lift heights. Finally, the contractor documents all pipe excavation, placement, and backfilling on Form CS6, signed by both contractor and inspector to confirm compliance. The 4.8 ROCK project by IRs and ARs represents a landmark achievement in modern construction, located in the historic University Place neighborhood. This multi-story facility was designed and built using the tilt-up method, which provides both efficiency and durability while allowing for architectural creativity. 48 Rock successfully bridges the gap between historic character and contemporary design, creating a structure that harmonizes with its surroundings while introducing a fresh, modern presence. Isamzu. Serving as the home for IRs and IRs, and Archie Plus, etc., the building reflects the core values of innovation and collaboration. Throughout its development, green building practices and sustainable principles were carefully integrated, underscoring the company's commitment to environmental responsibility. Constructed to meet LEED Gold standards, the project highlights a strong dedication to energy efficiency, resource conservation, and holistic design. At IRs and IRs, the focus has always been on understanding each customer's vision and delivering projects that fulfill those unique needs. 48 Rock stands as a testament to that philosophy. In modern underground infrastructure, replacing buried pipelines without causing major surface disruption has become a priority. As a result, trenchless technologies have gained widespread acceptance, with pipe bursting standing out as one of the most efficient solutions. Among the available systems, the Rebar-8 pipe bursting system has earned recognition for its compact design, impressive pulling power, and versatile applications. A guide says, to begin with, pipe bursting is a trenchless method used to replace old or damaged underground pipes with new ones of the same or larger diameter. Instead of digging up long trenches, contractors excavate only 2 small pits, a launch pit and a receiving pit. From there, a bursting head is pulled through the existing pipe. As the head moves forward, it fractures the old pipe outward, while simultaneously pulling in a new pipe, usually made of high-density polyethylene. Consequently, pipe bursting allows for quick and efficient replacement without damaging roads, sidewalks, or landscaping. This is particularly valuable in urban areas where disruption must be minimized. Therefore, a compact yet powerful system like the Rebar-8 becomes the perfect solution.
You want that other end down?
The Rebar-8 is a 30-ton pipe bursting system that delivers up to 3,000 psi of hydraulic pulling force, Designed for replacing pipe diameters from 1 inch up to 8 inches, it offers the ideal balance between portability and power. Unlike bulky systems that require large workspaces, the R-8 can be installed in tight and confined locations, such as basements, crawl spaces, septic tanks, manholes, or even under decks. Moreover, the R-8 is made of 2 main components, each weighing about 70 pounds. This split design enables workers to carry the machine by hand and assemble it easily on site. As a result, setup time is minimal, and contractors can position the unit exactly where it is needed, whether vertically or horizontally. One of the most remarkable aspects of the R-8 is its ability to be oriented both vertically and horizontally. When used vertically, the unit is perfect for narrow shafts, manholes, or basement access points. On the other hand, horizontal orientation is useful when dealing with underslab replacements or working in areas with soft soil. In fact, to ensure stability during horizontal operations, the R-8 includes a 24-inch by 24-inch aluminum resistance plate. This plate evenly distributes the load and prevents ground disturbance, making it highly reliable even in challenging conditions. In addition to its compact design, the R-8 offers excellent control options. Operators can choose between manual hydro control and a wireless remote control system. The wireless feature allows workers to manage the system from a safe distance or from the most convenient position, which enhances both efficiency and safety. Furthermore, the system can be powered either by a tractor's hydraulics or by its dedicated R-8 hydraulic power pack. The power pack is gasoline-powered, with a 14-horsepower engine delivering up to 3,000 psi at 12 gallons per minute. Weighing only 280 pounds, it complements the R-8 unit without requiring bulky equipment. Equally important, the R-8 is supported by a full line of accessories. These include bursting heads, cables, fusion weld machines, HDPE debeaters, and specialized tools designed for different conditions. Notably, the articulating bursting heads can navigate bends of up to 45 degrees, allowing the system to handle complex underground layouts. As a result, contractors are not limited to straight pipe runs. Instead, they can manage real-world scenarios where pipes twist and turn around existing utilities or structures. This adaptability further enhances the R-8's reputation as a versatile trenchless solution. First, the contractor prepares the site by digging 2 small pits, a launching pit for the R-8 unit and a receiving pit for the bursting head and new pipe. Next, the machine is transported to the launch pit and assembled. Thanks to its lightweight components, workers can carry and install it quickly. Then, the hydraulic hoses are connected to the power source and the hydro control is set up, either manual or wireless. After that, the bursting head is attached to the new HDPE pipe. The R-8 then begins pulling the head through the existing line. As it advances, the old pipe is fractured outward, while the new pipe is simultaneously drawn into place. Finally, once the head reaches the receiving pit, the operation is complete. The new pipeline is securely installed with minimal surface disruption. With pulling speeds of up to 8 feet per minute, the R-8 achieves fast yet controlled results. Thus, projects are completed efficiently without compromising quality. Beyond its design and operation, the practical advantages of the R-8 are significant. Contractors report that the system dramatically reduces labor time and overall costs. For instance, companies have used the R-8 to replace pipes under 240,000 square feet of slab in only 1 week. Without this technology, such a project would have required heavy demolition and much more time. Additionally, the R-8 allows pulling distances of up to 600 feet in a single run, covering long stretches of pipe without intermediate excavations. This capacity saves both effort and expense while minimizing inconvenience to property owners. Because of these benefits, many contractors consider the R-8 not only a machine but also a strategic investment that increases profitability. It is also important to highlight the safety and environmental advantages of the R-8. Since only 2 pits are required, there is much less risk to road users, pedestrians, and nearby structures. The reduced excavation minimizes exposure to underground hazards, while the wireless control ensures that operators remain at a safe distance. Environmentally, pipe bursting avoids unnecessary soil disturbance and prevents damage to tree roots, lawns, and pavement. Therefore, communities experience less disruption and the natural landscape remains intact. When comparing pipe bursting systems, several features make the R-8 stand out. First, it combines portability with strength, packing 30 tons of pulling power into a system that can be carried by hand. Second, it offers unmatched flexibility with both vertical and horizontal setup. Third, it is operator-friendly, with wireless control options and quick assembly. Fourth, it comes with a comprehensive set of accessories that allow adaptation to many job conditions. Finally, it delivers proven efficiency and cost savings, as confirmed by contractors across the industry. Therefore, the R-8 is not just another pipe bursting machine. It is a reliable, innovative, and profitable solution for today's underground construction challenges. Isalu. In conclusion, the R-8 pipe bursting system represents a new era of trenchless technology. By combining compact design, powerful performance, and operational flexibility, it enables contractors to replace underground pipes quickly, safely, and economically. Moreover, with its wireless controls, versatile accessories, and proven results in the field, the R-8 provides a clear competitive edge. The repair process of hyperbolic cooling towers begins with a comprehensive field investigation. Specialized technicians conduct condition assessments to identify the extent of deterioration and embedded steel corrosion. Using forensic analysis, the root causes of damage are determined, and service life projections are developed with and without repairs. Based on these results, repair alternatives are designed and evaluated for constructability, cost, and durability. When major repairs are required, unsound concrete is removed and surfaces are carefully prepared for material replacement. Corrosion control methods are then applied to stop further reinforcement degradation. Solutions often include galvanic protection systems, such as life jackets and life panels for columns and ring beams. For larger surfaces, engineered multi-zone impressed current systems are installed, using advanced electrotechnology to regulate current flow and protect the structure. These steps, supported by extensive manpower and quality assurance, ensure the tower's structural integrity and long-term service life. The reconstruction of the Almaty-Kokpek-Chunja-Koktal-Korgos road involves extensive earthworks, asphalt paving, and structural improvements, enhancing durability, safety, and connectivity while supporting regional economic development and providing smoother, more efficient transportation for communities. Blakeman Steel, a family-owned company founded in 1988, is a leading structural steel erection and tilt wall specialist based in Fort Worth, Texas. Known for quality and dependability, the company has built lasting relationships with fabricators, contractors, and developers, completing projects nationwide. With over 200 years of combined management experience, Blakeman Steel brings expertise to every project, from warehouses and offices to schools, churches, industrial and multi-story structures. Their skilled crews handle not only structural steel, but also stairs, canopies, mezzanines, railings, ladders, and ornamental work. Safety is a top priority, supported by thorough training and continuous certifications. Equipped with a fleet of cranes up to 250 tons, aerial lifts, forklifts, and trucks, Blakeman Steel is fully prepared to deliver reliable, safe, and high-quality results. The process of erecting the steel frame begins with the arrival of prefabricated beams, already cut, drilled, and marked according to architectural plans. Each piece is clearly numbered to indicate its exact position in the structure, ensuring that the crew can follow the engineer's drawings with precision. First, the crane plays a central role in lifting the massive steel members, some as heavy as a large car. The crane operator uses fingertip controls to maneuver the beams, while a spotter ensures safety by keeping workers clear and maintaining distance from high-voltage overhead wires. This coordination is crucial for avoiding hazards and guiding each beam safely into place. The erection sequence starts with upright columns, which are lowered into studs embedded in the concrete foundation. Workers carefully position them east-west and north-south to match the detailed drawings. Cross beams and floor joists are then hoisted and fitted, with crews aligning each element into its intended location. At this stage, most beams are only loosely bolted. This temporary fitting allows enough flexibility to push, pull, and align additional members as the frame takes shape. Only key structural points are tightened to hold the skeleton stable. Once the primary frame is assembled, leveling becomes the next focus. Using string lines and levels, workers ensure that every column and beam stands perfectly straight and square. This is essential, not only for structural stability, but also for the precise function of future installations such as stairways and the elevator shaft. Before welding or final tightening, each component is checked again to confirm accuracy. After alignment is secured, crews proceed to place metal decking across the beams to form floors. On the first floor, decking is installed while openings for the stairwell and elevator are left clear. Concrete is poured atop the decking to create the slab, binding the steel and forming a solid platform. The process is then repeated for the upper floors, with decking lifted and positioned by the crane and guided by workers into place. Throughout the project, specialized roles ensure progress. Some workers tighten bolts, others verify levels, and still others coordinate beam positioning. This teamwork transforms hundreds of individual steel pieces into a unified frame. Finally, after weeks of careful work, the steel structure is completely erected, leveled, and secured. The result is a solid skeleton capable of supporting all subsequent construction phases, from walls and utilities to finishing details.